Thank you much for coming. It's an honor to be here. In fact, this honors they give me, I always say that it's really because of the lack of having, over the course of my life, wonderful authors, and in particular, the co-authors that accompanying me in this trip are Pablo Braña, Paz Espinosa, and Diego Ferrat, who are to be, given the benefit for anything that is here, and I'm guilty of anything that I don't like. All right. So we started this project. So let me start with the introduction here. We started this project thinking about a series of projects on climate change, or a project that in fact we wrote with Matt for a ERC synergy, which we didn't get. We're going to do at least some of the things that we promised anyway with some of the funding. And the idea is the following. There is a bunch of problems in reality. One is climate change, that have two characteristics that are important. One, they require for people in order to achieve a goal. And the other is that uncertainty is big, but also not particularly well structured. So what this means is that, so we have here a couple of examples like this. One is climate change past, climate change future. Interestingly, so this is a segregation of the potential causes for climate change in the past. And you can see that here, for example, you can see this is one aspect of the climate change, and this one was tropospheric aerosols, which I have no idea, but Maria can explain. Tropospheric aerosols decreases the amount of warming in the Earth, but you see here that there is a big uncertainty about the exact effect of tropospheric aerosols. And other things that also have white bands here, carbon dioxide has an impact on temperature, but it's not like certain too much. So there are big amounts of uncertainty in the effects, even in the history of climate change, and moreover towards the future. So these are different paths of climate change in the next 100 years, and each of these lines. So this is taken from the last IPCC report, and I think this one is from a paper. This is from the IPCC, and it gives you the likelihood given different abatement efforts. So this is, I think, the top one is under business as usual, and the others under different abatement efforts. But for each of these ones, there is a big uncertainty. Yes. Okay. Yeah, it might be easier to understand me this way. So I've been it twice, and I've had the chances that I can infect anyone are pretty low. So anyway, so the point of this is huge uncertainties over many of these things, and this includes whether our efforts are going to have an impact. Okay, so that's the motivation for this work. That there are many things in life which have two. One is in order to achieve, or at least evade or have a smaller impact of climate change, we have to do lots of joint efforts. So there is a strategic complementarity in here, but there is a big uncertainty. And we're thinking like this. So there are many important social projects that these two characteristics. So complementary investments by many people and significant and badly defined uncertainties. Climate change is one example, but innovation is another one. In order for us to get to a point where we all have electric, something that seems desirable, there has to be people that are doing things at the same time. So better batteries have to be discovered. There has to be a network of, places where you can plug your car. All these things have to happen at the same time to go to the electric mobility, for example. And in a world in which we all have to do these things at the same time, if, on the other hand, these probabilities have wide margins of uncertainty and, in a sense, the literature has called these wide bands of uncertainty that are have called these ambiguous probabilities. So, multiplication of ambiguous probabilities in like this. On the one hand, a typical way decisions have handled a world in which uncertainty and risk, that is with badly defined probabilities, is using min-max ways to think about them. In a sense, I take of all the probabilities that happen, the worst one, the one that leads to the worst outcome, and then I optimize, taking into account this worst probability distribution of the model. Now, focusing on a pessimistic scenario might lead us to increase effort. If we think that climate change is going to be very bad, then we might decide that we really want to, take a big effort to avoid climate change. But on the other hand, pessimism can also affect the chance of success. So if I'm pessimistic also that my effort is going to be successful, then I might not want to make the effort. Okay. So these two things already say that this problem is complicated. In addition, and more importantly, and perhaps the biggest story of the work that we're doing here, is that this problem of decision theory with ambiguous probabilities has been studied under single-person decision problems. That is, present people with several probability distributions and tell them some of these or one of these is going to happen. I'm not sure why, what decision you want to take. But there are no strategic interactions there. There's very little in terms of theory or experiment that deals with worlds in which there are strategic interactions and at the same time there are ambiguous probabilities. But the world that we're worrying about, this world of climate change and climate change abatement, is one in which there are strategic complementarities, and therefore we cannot evade it if we want to understand this problem. That's the motivation. It's understanding a world in which there are strategic complementarities and there are ambiguous probabilities, put them together to see what happens in there. Okay. By the way, I didn't mention this, but feel free to ask questions anytime you want. Don't wait until the end if you.
In this case, for instance, the worst situation, minimizing probabilities with about function, a string function.
Yeah.
So you have
Yes. That's what the min-max utility is one of the ways. Of course, there are many other ways people have handled this. So we're going to focus on min-max because we don't know how people behave really, but I don't know, Marinacci, Ristichini, and Maccheroni have this variation approach. There are people who have done a combination, so a linear combination on min-max and max-max. So the worst, thinking of the best, and some linear combination of both. And there are some smooth versions of the problem. So people have dealt with this in many ways. We are going to present one theory, because the is the extent, and in this case, we are going to do it with min-max. Obviously, there are other ways. I don't think this will matter very much, but there are other ways to deal with it. Yes?
Each agent has many probabilities, distributions of the possible consequences of its acts.
That's right.
And every agent has a different set of probabilities.
In the experiment, no. Everyone is given the same set of probabilities. I'm going to show you this, but yeah, everyone is given, there are several treatments of the experiment. In ones you know the exact probability, in others you have range, but everyone is given the same range. Okay, so what we actually do is a randomized online experiment, and another important difference between this experiment and others that people have done is we use a representative sample in a medium-sized country, Spain. Participants are going to play a threshold public good experiment, and they are to contribute to avoid probabilistically a bad outcome. The uncertainty is going to be about the chance to avoid the bad outcome, but also about the threat this happens. Since there are probabilities about both the outcome and the threshold, and they can both of them be ambiguous, we're going to have 2 times 2, 4 treatments that we're going to analyze. In addition to the main thing that we want to test, which is this attitudes of people towards contributions in a world of this form, we're also going to measure risk aversion, ambiguity aversion, CRT, which is cognitive, was a measure of, in a sense, how quick you want to take decisions. Social preferences, time preference, ability, and then also a Socio-Demographic Questionnaire that in particular includes many questions about attitudes towards climate change. Although the experiment is not framed as a climate change one. Summary of results, in case I go over time, average treatment effect is a very precise null for all treatments, meaning the amount of contributions is the same independently of whether the uncertainty is ambiguous or not in any of the dimensions. Risk aversion and ambiguity aversion is going to significantly decrease contributions, and risk aversion and ambiguity aversion are quite, but not perfectly related. And the reason why we did all these measures, these alternative measures in here, is we thought that there's a potential that these effects might be different classes of people. It might be that, you know, I don't know, the impact ambiguity is bigger for females than for males, or it might be that for more educated people than less educated people, people who know more or less math. It could be, and there were several things that in principle affect this, and so we tried to see whether, in case like this, where we find a null, whether the reason is that it affects positively to some and negatively to others. It's just that it's a null effect for everyone, that it's a null effect for all the groups. So it's not like there are some opposite effects happening in different groups, and that's another of the discoveries. So those are the main results. There are, of course, lots of experiments that have been done. So ambiguity should increase investment in climate change. That's a theoretical exercise. Policymakers are ambiguity averse. So that's a paper that was done in the Paris negotiations for climate change a few years ago. We see that kind of, in a sense, ambiguous results about experiments on decision theory, not on games. Farmers invest more on adaptation if the risk is ambiguous. There's ambiguous climate change reduces index insurance demand. So there's a variety of resources that tell kind of different attitudes. Sometimes people invest more, sometimes people invest less. Okay, so I think that's the important thing has been said. So let me go to experimental. I'm going to go through the experimental design first, so I understand what we're doing, and then we're going to do what's the theoretical benchmark that gives us hypothesis in this experiment, and then we'll go to the results that I've already started to discuss. Okay, so as I've already mentioned, we have 2x2 treatments. There can be risk, ambiguity in the threshold and in the probability of averting the disaster. It's going to be, in fact, framed in the case of a robbery. You're going to people have to pay to avoid being robbed, and have to invest enough. If they invest enough, then it's more likely that the robbery is avoided. Okay, so there are 4 treatments. One is risk, that is a probability that is well defined. In the price for avoiding the robbery, and in the outcomes of risk, there's so well-defined probability in the price, but ambiguity in the robbery, ambiguity in price and risk, ambiguity in both. Okay, so those are the 4 designs. Okay, and here is an image of the instructions that we have in there. So that's what people saw in the experiment, the participants. So in this task, there are 5 participants. Each of you is going to, so there are, we put 25 euros in a strong box for the group, so 5 for each one of you, but there is a problem. There is someone that might want to rob you. Now, if you can take a precaution to make the strong box more secure, you might avoid the robbery. And the key thing that changes is this part over here. That changes between the treatments. So that's these are the instructions that they put here are for the risk, so well-defined probability. And the well-defined probability tells you that you can avoid the robbery with 90% if you invest enough, and only with 10% if you don't invest enough. So that's the well-defined probability. And how much is enough? Enough is either 5 or 10 euros with equal probabilities. So well-defined probabilities that you avoid the robbery if you put enough money in the, or you give enough, you give that money to the person that is going to avoid the robbery. And the distinction is that's the general, that's the well-defined. In the not well-defined, this 90% and 90%, you're told is at most 20% of with at most 20% probability you avoid if you don't pay enough, and with at least 80% you avoid if you pay enough. Okay, so you're told some range, some probability between higher than 80%, I don't tell you what, and some probability lower than 20%, but I don't tell you what. And that's the way it's described, and then we mix. So, so in the first one, you're told exactly. So it's ambiguous only for ability, but not for the amount of money that needs to be paid, and in the others is fine. We change these things, but those are the 2 kind of parameters.
Excuse me, the amount of money, how do you change it? Or?
No, the money is always there. It's 25 and 5. So 5 person. Sorry. The amount of money is this 5 or 10. It's either 5 or 10 with 1. And in other case, we say either 5 or 10. I will be covered. So those 2 are the 2 parameters that become ambiguous. So that's the way they ask the main thing. So that's the main thing we want to know. Is whether they invest more here, there's no ambiguity, or in here that there's ambiguity in here. Here, this is our where do you invest the most? Where everyone, everything is best known, or where things are not that well known? This is actually, this RR is how reality is. So when you're presented. Now this has changed a little bit, but I think for a long time in climate change, the way climate change there was not really a distribution. You were told this is the range of possible outcomes, and you weren't told, and this is the most likely, and this is the probability. There was never a probability distribution. I think maybe the last IPCC report they are doing it, or they said they would do it, that I don't remember exactly, but for a long time, climate change was presented in a very ambiguous way. And that's why I thought that this might be an issue. Okay, now, I mentioned that there are covariates, and the covariates that we want to measure is, for example, ambiguity aversion. Here is 2 options, which you can extract from an urn, you can take a decision from an urn with unspecified probabilities, and you can you might need to pay something to avoid extracting your money from the third. So you're maybe let's describe measure as willingness to pay to avoid the ambiguous earn. Similarly, for risk aversion, we do it similarly. So it's how much do you pay to avoid. So that's the certainty equivalent. We're trying to measure the certainty equivalent to this earn and to the ambiguous earn. And that's how you measure risk aversion and ambiguity aversion. Social preferences are measured using mini dictator games. And in this case, we tell them that you have an amount of money to distribute between two people, and there are several of these opportunities, and one is one for you, one for the other, or 0.8 for you and 1.6 for the others. And there's a bunch of these. You're going to be presented with, I think it's 6 different of these dictator games, and random your in these things, one of them is going to be chosen randomly. Okay, so that's the way that we measure this. In addition, we've had a cognitive reflection test. So these are a bunch of questions that look a bit like IQ questions, little mathematical problems, but basically what this measures is, so they have several answers. One is the kind of obvious answer if you don't think too much, and the other is the true answer, which is something different. And when you answer the kind of this, the more or less obvious one, it's usually wrong, but it basically reflects that there is someone that didn't think through the problem too much. It's kind of impatient, cognitively impatient, if you want. So that's what cognitive reflection test measures. We did some simple math comprehension tests, so division, some compound interest, some time preferences test, which was not incentivized. This was a one-shot experiment in kind of a survey, and a good time preference test requires that you pay people either or later. So you can choose whether you want €1 now or €2 in 1 week or in 2 weeks, and then you have to pay people in 2 weeks. And this logistically was a mess, so we didn't incentivize it. There is some evidence, so Pablo in particular with some co-authors have been working with people that say that the results you get in non-incentivized time preferences test are similar to what you would get in the incentivized one, so we're not too worried about this. Also, it doesn't seem to have an effect, but in any case. There's a socio-demographic questionnaire with 34 questions, which has the gender, education, profession, income, blah, blah, but also attitudes to climate change that are taken. It's basically we take the whole module of climate change questions in the Eurobarometer. Eurobarometer has a bunch of questions, and we asked.
You have 34 in total?
Yeah, in total. No. So in the demographic, I have 34. Yeah. So it was a not inconsiderable amount of time that people take to fill out everything. We did with a company that's called ASU. Just very professional. So they did things very well, rapidly. So we were very happy with this. Okay, so those are the covariates. In terms of data and sample, it's of course representative in the sense of by region, for example. You can see that the averages by region are very similar to the population. In terms of other characteristics, it's also representative in age. We wanted it to be in gender, education. In these three characteristics plus it was representative. Of course, we don't know about the others because there are no things in. Yeah, so there are. Oops, I don't remember what are the rest in there. Can I, if I say height here, is that one? Okay. Okay. Okay, so this is something, okay, so that's why we put it here. So there is a correlation between ambiguity and aversion. People that are ambiguously averse, they also tend to be risk averse, but it's not a perfect correlation. So it's some correlation, but it's not perfect. And that's going to be important for the results later on. Okay. Yeah, thanks. Now, in terms of balance across treatments, you can see that basically there's one thing that is almost significant here, but it seems well balanced across so the randomization between treatments seems to work well, which is always good. Except, no, here, age for one of the treatments was not well balanced. But since we're having so many things in here, the fact one of them appears significant, it's in a sense reassuring. It would be surprising that when we are, measuring all these differences, none of them appears significant. And yeah, I don't think this had any clear implications. Okay, so theory and hypothesis. So this is a relatively short section because we don't do anything, very easy. We take the following approach. So essentially what we're doing in this experiment is we have people contribute, so they contribute this CI is the amount that they contribute to this public good, and then this is the probability that you actually obtain the pay. So 5 minus C is 5 is the endowment, C is how much I contribute. So I get the 5 minus C if and only if it's not stolen, and the probability that it gets stolen is DC. And here is where the strategic interaction comes. One of the nice things about this design is that then the kind of dealing with ambiguity aversion in a strategic context is relatively easy because strategic interaction happens at the level of the P. If you had a more complicated game or a different game, dealing with the ambiguity aversion and in the strategic context would be different. In this case, it's one of the nice things about this design. Okay, so in the benchmark, safety loss is either 5 or 10 with 1/2 probability, and then that this probability facing the different levels of contribution. So if the total contribution is below 5, then 0.1 is the probability of surviving. If the contribution is between 5 and 10, well, you average out these two probabilities, and if it's between 10 and 25, the contribution, then you avoid the catastrophe with 0.9 probability. Because relatively simple structure, then the under ambiguity of the min-max persuasion, like I said, we haven't examined what it would be with the value approach. It would be extremely maximized with respect to your contribution, the minimum of the probabilities in this case, minimum with respect to E. So you choose always the most the worst. And this kind of simplifies a lot the game. So in each case, the ambiguity game that is a relatively simple game. And now we have 4 games, and all we have to do is analyze the equilibria in the 4 games. This is to do the analysis. You get a relatively simple set of hypotheses. So basically, there are only 3 possible total levels of contribution in equilibrium that happen: 0, 5, or 10. There are risk-neutral preferences, and there are several things that can be in equilibrium under risk, but there are things that cannot be equilibria under treatments. But we move to, so long as there are some people that are risk-loving, then the set of equilibria decreases much. To the point that only this kind of equilibrium, so no contribution to equilibrium under risk, under risk can be this is the only possible equilibrium. Now, 5 is the only total contribution is the only equilibrium under ambiguity. So W means weak. It's a weak equilibrium otherwise. And then the only equilibrium ambiguity is contribution. So in a sense, you can see that ambiguity in principle in a world in which people are have these max-min preferences and at least some people are risk-loving, should be under ambiguity in the other. So it push you towards contributing more. It also should be larger in the ambiguity than in the other treatments. It's a bit harder to rank the other two, but in principle, at minimum, they should be more polarized in RR than in RR. So it's a fairly, thanks to the simplification we've done, it's relatively simple to generate hypotheses. One important caveat: the way one thinks we've thought about taking here is a way in which there is no uncertainty about the equilibrium. So people know what the equilibrium is. Okay, so in a sense, we are assuming that the only uncertainty is the environmental uncertainty, the uncertainty about these environmental parameters. But people somehow, it's a standard, I know in game theory, it's a standard to think that people know what the equilibrium is, but it might explain some of the results because the theory is clear. If people under these conditions that don't seem particularly stark, we should have more contribution in one than the other, but importantly, people are not uncertain at all about what the others are going to do. They know that they're going to play the equilibrium, and that's it. Okay, so there's no uncertainty about whether the others are close enough to the equilibrium. No, that's it. Okay, so model, hypothesis, design, so I can go now, so it's not to take much time, I can go to the results. So we're going to present regressions later, but this is already telling you a lot. So this is mean condition in the public good games across treatment, and the 95 confidence intervals. That basically there's nothing there. The total amount contributed per person is actually pretty high. Remember that if you get 10, doesn't matter ambiguous or not, you're guaranteed to go to the highest probability of avoiding the problem. And people on average are contributing much more than 2. So this means that basically the problem, the robbery is avoided most of the time. Okay? So that's important to know. But it's avoided equally in all events, whereas the theoretical result tells you that it should be more in ambiguity than unperfect sum. Now, just to show something different, there's a difference in how much risk-loving people contribute and risk-averse people contribute. The risk-averse neutral people contribute less than the risk-loving people, which could be a bit counterintuitive. I don't know. So this is the risk-neutral and risk-averse contribute less, and ambiguity-neutral and ambiguity-averse people contribute less as well. Okay, so this is that it's not that uncertainty doesn't matter, it's that uncertainty matters, but it matters whether ambiguous or not. So in a sense, I would say that this that it validates, but the approach the IPCC of presenting bands is not terrible, in the sense that if you had given very precise distributions, you wouldn't have made any difference. Because what matters is the existence of uncertainty rather than the fact that it's or not. So risk-averse people, decide not to contribute, and there's quite a lot of them in the world. So this is uncertainty is important, but the ambiguity per se is not important. Okay, so this is the same kind of solve the regression form. So you can see that the coefficients for the treatments, there's no stars in there, so there's nothing going on. You could interact with the variable ambiguity aversion, just to see if at least the treatment makes a difference in the ambiguity aversion. That's what we have to here, but it doesn't make a difference. Beliefs indeed make so if you believe people are going to contribute more, then you want to contribute more. So that's an important observation here. If you think that people contribute more, then you want to contribute more, which makes sense given that this is a world or a problem which has strategic complementarity. That's logical. So it's not really irrational. They're just, if they think others contribute more, then they want to contribute more. And ambiguity does make contribute less. It's just that interactive treatments, not. It's just for all the treatments. All right. Same thing, but with conversion. Again, the beliefs matter. So you believe that people are going to contribute more, you contribute more.
How do you know the beliefs?
We elicit beliefs. I didn't mention when we tell you. So we ask people, how much do you think others are going to contribute?
You check the result, the exact information, what people. Because when I behave in a public game, if I was sure he did not contribute, I would say he did not contribute. Maybe I don't know.
Yes.
So I would say, but I don't know.
Yeah. So that's a good question. In fact, I think we'd like to do eventually when we get more money, because we get like 35,000 euros, something like this. So that's not a small budget. But we would like to do this, at least a smaller experiment with a few people, but repeated. So do it once because it's like you say, it could be that I see others are contributing less, then I contribute less, and that's some occurrence in public good games. There is the possibility, at least here, that this doesn't happen because this is a combination game, so it's a threshold point, and people are contributing above the threshold. So in principle, people say, okay, others are contributing enough on average, so maybe I should contribute enough. But there's a possibility that you start reducing at some point, you cross the threshold down, and then boom, you go all the way down. So that's another possibility that could happen. And we really, so thanks for sharing, because we really would like to do this, see what happens over time. Because this, if in one of the papers I mentioned in passing, well, I wrote in passing, but I didn't have about this paper here, by Milinsky and company. So there, it's really thought out to model a problem like this, because people contribute every period, but you add up the contributions, and if by a certain point in the game, so after, I remember how many periods, 20 periods, let's say, everyone has contributed enough, they avoid the catastrophe, and otherwise you don't avoid the catastrophe. And so we want to run this repeatedly, but it's an alternative. An alternative is to see, I period one, and see what others are doing. If they're doing enough, maybe next time I don't, but in principle, I should contribute dynamically, and that's a little bit more similar to climate in some ways. It's a dynamic, you accumulate a stock. So Milinsky wanted to model a game in which you accumulate a stock, and if you do enough effort, then you avoid the catastrophe later on. That's more or less the. So that's an alternative way. The problem is that this with 1,500 people like we were would be difficult. So one or another dynamic version is we plan to do it with a smaller sample of 100 students or something like this. It's not representative, but would give us an idea if the dynamics is different.
Did you compensate your participants?
Yes. They all get paid for. The only thing that wasn't incentivized was this the practice test. All the courses were incentivized. That was expensive. And we had to pay a lot of money to the subjects. So they ended up since it costs 25,000 and there are on the order of 15, 20 euros. So 5 is the max you get in the contribution gain, but then you have to pay them for their time and for correction tests and blah. So they end up earning about 20 euros per person, 15 or 30 euros. Okay, so more regression results. I'm almost done. So other things that we look at, female, we thought maybe females want to contribute more. It's been observed some contribute more to public good games. It doesn't seem to make a difference, or at least the ambiguity doesn't seem to make a difference, but even females per se doesn't seem to make a difference. Other interaction is with CRT, maybe people that don't think through the problem, we thought, people that are impatient. That does make a difference. So, CRT that are thinking the problem more, a little bit, and conversion is mathematics, it doesn't either or interaction with the other things. And then the beliefs already mentioned that they interact with this difference. It doesn't seem to make a difference. The difference. So beliefs. So we know that people believe others contribute more. In this that's what here. Which makes us think that people in their mind were in the different. And then interactive. So this is belief interactive with ambiversion, and then belief with discoversion. And that's basically a large online experiment. You've seen the main result and an additional result. Qualification probably should reduce uncertainty and risk, both in our percentage of social problems like climate. Every effort to reduce the uncertainties that are associated with either the consequences or the things that you can do to decrease climate change probably welcome, and there's more is needed. Dynamics very much in our mind, for sure. That's all. Thank you very much. Okay, I didn't get to.
I have some maybe almost. Just a quick one. Thank you for your presentation and your work. It's very interesting. When we talk about uncertainty in this context, is that, and when people contribute or not contribute to the public good, I mean, the loss of not contributing is somehow limited. In the sense that, in the box there's an amount between 5 and 10 euros, correct? Have you thought about these different treatments in which you save loss of your savings and potentially the savings of the economy? Just climate change.
Yeah, no, that's a good point. I wish I had the money to do an experiment like this. Could potentially do this with a device experiment where we tell them you're going to lose some money. Yeah, and we could see whether people react differently in that case. And we could put like realistic figures, like we take from IPCC, we need to how much we would lose. I don't know, in 20 years from now in terms of GDP if we don't do anything, and how much we have to contribute now to avoid this. So it's an interesting idea. We could without incentivizing, then now sadly we would need to publish this in a non-economics journal because the economics profession is a bit too kind of in terms of it's not incentivized.
Yeah.
But I think for a more receptive audience, this might make sense.
First of all, thank you for the presentation. And my question is related to, do you think the results by institutional economics in this study has been done? Because, for example, there are several studies of austerity, the very first talking about austerity avoidance in the cultural basis. So, the question was related to could ambiguity be also related to the institutional environment?
It's possible. It's possible. We would need to do the experiment. I mean, I think the right way to answer this is we need to do the experiment. I'd conjecture that now that we are outside the presentation, what I conjecture is that the main failure here is that there's the strategic uncertainty probably dominates. I have an early experiment I did many years ago with Giovanni and other co-authors in which we were testing social preferences in a strategic context. And then, so it was also a kind of coordination game, and then people could they could take an action, or they could approve an action that increases inequality but reduces the strategic uncertainty. So that creates a trade-off between the two. And even people that were measured separately, that were quite inequality aware, were willing to accept quite a bit of inequality in order to avoid the strategic uncertainty. People, at least from that experiment, people really hate not being able to predict what others are going to do when it impacts on their own. So I expect that what's here is if I know, and that goes back to your question, if I know that others are going to contribute, that makes me much more likely to contribute. So we know this from the beliefs elicitation that we did and so on. So I suspect that results here to, for example, why people and the risk-averse people contribute less is probably they hate the strategic uncertainty of not knowing whether we're going to be. So it's already pretty bad to make a contribution, but make a contribution and then losing everything because the other idiots are not contributing, that's pretty bad. So I think that really plays a role in what we're observing here.
I should ask about beliefs. What scale are their beliefs? Here.
I think what we ask is how much did you think the others in your group have contributed? We did this was a survey done in the general population, and I know that the usual thing to ask people, how much, like almost give me a proud distribution of how much others have contributed, but we thought that's it, so we just asked how much.
I was thinking to write but maybe interesting to ask about some environmental
but this, okay, sorry. So this is in the questions. We tried also in these questions of the web, and there you have. Do you think the world is doing enough about climate change? Your government is your responsibility. Is your government responsibility? So it's I'd say a third of the questions those words. And then maybe we should try to get kind of some principal component or something of this, because there's quite a lot of questions, not one of them, but try to get a principal component in this. That could be. No, it's, the only answer cannot do with be a lot of money, but maybe potential question might have some good answers.
It's true. There is one thing that is to say. Probability is
with cyanide? I was going to say that if I try to pass to the ethics committee at Carlos 3, they're not going to be very happy. Yeah. No, but in there's been pretty aggressive that have been done in psychology that are very close to what you're suggesting. Where you have basically a confederate threatening to kill you, and then it's not obvious that it's not true, and we could, so that's another way. Go to the psychology lab, and if the psychology lab we can do something a bit more. Yeah. Yeah. No tenía posibilidad. Good. All right. Thank you.